Hello everyone, this is John Hashmet and welcome to Physics Simply. In this video I will be solving the paper 2 exam for May-June 2020 variant 2. So let's get started. Question 1 says 5 athletes P, Q, R, S, and T compete in a race. The table shows the finishing times for the athletes. Which statement is correct? Either athlete P1 or S1, and they were 0.70 seconds or 1.90 or 1.3 or 2.10 ahead of the second place. First of all, to consider which one won the race, it would be the shortest time to finish the race. By comparing these values, the shortest time is for athlete P, so it's not C nor D. Then the second place is the second shortest time, which is for athlete T. If we subtract 23.20 minus 22.50, you get 0.70 seconds. So the answer is A. Question 2 says a student investigates the motion of a ball rolling down a slope. The diagram shows the speed v of the ball at different times t. So we have 0, 0.2 seconds, 0.4 seconds, 0.6 seconds. That is a step of 0.2 seconds every time. The first time it increased from 0 to 2.8, the second time from 2.8 to 5.1, the third time from 5.1 to 7, and it asks which statement describes the motion of the ball. Is the acceleration not constant? Acceleration is negative, speed is decreasing, velocity is constant. First of all, the speed is not decreasing and the velocity is not constant since the direction of motion keeps changing and the magnitude of the speed keeps changing. Acceleration is negative means that it is decelerating, but in this case it is accelerating, so the only option is option A, where it says that the acceleration is not constant. And actually, if you use acceleration equals v minus u over t for each step, that is 3 times here, you will find that the acceleration it will not be constant. Question 3 says which statement about acceleration is correct? It is related to the changing speed of an object. Yes, it is, but we will read the other sentences. It is distance an object travels in 1 second, that is speed. It is a force acting on an object divided by distance. No. It is a force acting on an object when it is near the earth. Also no, so the answer is A. Question 4 says which statement correctly describes the effects of placing a heavy load in a car? It is easier to accelerate the car and easier to bring it to rest. No. It is easier to accelerate the car but more difficult to bring it to rest. No. It is more difficult to accelerate and more difficult to bring to rest. Yes, this is the correct sentence. So it is C. Question 5 says a space probe is taken from the Earth to Mars. The force of gravity on the surface of Mars is less than the force of gravity on the surface of Earth. How do the weight and mass of a space probe on the surface of Mars compare with their values on the surface of the Earth? First of all, the mass does not change, so it's unchanged. The weight decreases as the gravity field strength decreases, so on Mars the weight would be less or decreases. So the answer is B. Question 6 says water has a density of 1000 kg per meter cubed. A rectangular swimming pool has an average depth of 1.6 meters. The length of the pool is 25 meters. The width of the pool is 10 meters. What is the mass of the water in the swimming pool? We can use the equation density equals mass over volume. So mass would be equal to density multiplied by volume, and the volume can be calculated by multiplying the length, the breadth, and the height or the depth of the swimming pool. So we multiply all these values, 1000 times 1.6 times 25 times 10, and that would give us an answer of 400,000 kilograms. Question 7 says a satellite orbits the Earth at constant speed in a circular orbit. Which statement is correct? The resultant force on the satellite is 0. No, since the velocity is changing due to the change in direction. When you move in a circle, the direction keeps changing, so there is a change in velocity, which means there is an acceleration, which needs a resultant force, so it's not 0. The resultant force on the satellite is towards the Earth. Yes, that is towards the center, acting as a centripetal force. The resultant force on the satellite is away from the Earth. No. The resultant force on the satellite is in the direction of motion. No, it's perpendicular to direction of motion. So the answer is B. Question 8 says two forces P and Q act on an object. Which diagram shows the resultant of the two forces? If we are going to draw the forces starting from the same point, that's a tail-to-tail drawing, which means we need to close the drawing as a parallelogram, not as a triangle. So in all these diagrams, they are tail-to-tail, tail-to-tail, so we should draw them as a parallelogram to finish the drawing of the resultant. So it's not B and it's not A. But the direction of the resultant force should be in the direction of the original forces, not opposite to the direction of the original forces. So the answer is C. Question 9 says an object is moving at positive 3.0 meters per second. A force acts on the object. After a time, the object is moving at a velocity of negative 4.0 meters per second. The mass of the object is 5 kilograms. What is the change of momentum in the body? The change in momentum can be calculated by multiplying the mass by the change in velocity. So the mass was 5.0, the final velocity is negative 4.0, minus the initial velocity, which was 3.0. So that gives us an answer of negative 35 kilograms meter per second. Question 10 says, which energy resource is not renewable? Geothermal, nuclear fission, solar, or wind energy. All these resources are renewable except for nuclear fission, which depends on nuclear materials or radioactive materials, which in turn change their structure and will no longer be available, so they will run out, so they are not renewable. Question 11 says a car of mass 500 kilograms is moving at 10 meters per second. The engine does work on the car and the speed increases to 16 meters per second. How much work is done by the engine to increase the speed of the car? We have a rule that the work can be considered equal to the change in energy. In this case, the type of energy we're talking about is kinetic energy. So the work done would be equal to the change in kinetic energy. So half mv squared minus half mu squared, or we can simplify this, half m multiplied by v squared minus u squared, where v is the final velocity and u is the initial velocity. And then substituting by the numbers, half times the mass 500 multiplied by 16 squared minus 10 squared. This would give an answer of 39,000 joules. Question 12 says the diagram shows a solid block resting on a bench. The dimensions of the block are shown. It's 40 by 20 by 80. And we have different faces, P, Q, R. On which labeled surface should the block rest to produce the smallest pressure? Smallest pressure means the largest area. Since the weight, which is the force, is the same, so we need a larger area to create a smaller pressure. So the largest area would be 80 multiplied by 40. This 40 can be the side on this part, so it is face P. So the answer is A. Question 13 says an object is 60 centimeters below the surface of a liquid. The pressure due to the liquid is, at this depth is 9,000 Pascal. What is the density of the liquid? Using the equation pressure equal density times gravity acceleration times depth, we can substitute 9,000 is equal to density, unknown density, multiplied by 9.8 multiplied by the depth, but it should be in meters. So instead of placing 60 in the equation, it would be 60 divided by 100, so it's 0.60. Then we divide by this bracket on the other side, leaving the density the subject of the formula. This would give a value of 1530.6, so approximately 1500 kilogram per meter cubed. Question 14 says which row describes the forces Question 14 says which row describes the forces between the molecules and the motion of the molecules in a solid. Forces between molecules in a solid are strong. Motion of the molecules, they vibrate only, not move freely, so the answer is B. Question 15 says wet clothes are hanging outside to dry. Which condition decreases the rate of evaporation of the water from the cloth? Folded cloth, yes. Higher temperatures, that would actually increase the rate, not decrease the rate. Water cloth, it should have no effect. Windy day, it should increase the rate, not decrease the rate of evaporation. So the answer is A. Question 16 is about thermometers, so it would not be in the new syllabus, but I will solve it anyway. You can skip this question. The diagram shows a liquid and glass thermometer. The design of this thermometer includes the following features: a liquid which expands linearly when it is heated, a glass bulb which has a thick glass wall, a capillary tube with a very small diameter. Which features increase the sensitivity of the thermometer? Only a capillary tube with a very small diameter would cause the sensitivity to increase, so it would be 3 only, so the answer is D. The next question says the diagrams show 4 blocks of steel, same material. The blocks are all drawn to same scale. The same quantity of thermal energy is given to each block. Which block shows the greatest rise in temperature? So using the equation Q equals mc delta theta, we have C and Q the same. Q same amount of thermal energy, C is the same for the same metal, which was steel. This means that as mass increases, the rise in temperature decreases, and vice versa. So for the largest temperature rise, we need the smallest mass, which is in block A. Question 18 says a room is heated by a radiator. The diagrams X and Y show 2 possible circulations of hot air which heat the room. Which diagram and reason explain the heating of the room by convection? In convection, hot air rises and cooled air sinks or falls. So near the radiator, the air is hot and rises. So this diagram is false. So the diagram would be X, choosing from these answers. And air density decreases when air is heated, or air density increases when air is heated. As the air expands due to heating, the volume increases and the density actually decreases, so the answer is A. Question 19 says 2 copper containers P and Q are filled with hot water. The diagrams are both drawn to the same scale. Container P emits more infrared radiation from its surface than container Q. What is a possible reason for this? So the amount of heat radiation depends on several attributes. First, the temperature of the object. The higher the temperature, the more radiation it will emit. Secondly, the surface area. As surface area increases, the rate of emission increases. And the last one is the color of the surface. The darker the surface, the higher the rate of emission. The surfaces of P are painted white and the surface of Q are painted black. No, they should be darker on P if P has a higher amount of radiation, so A is wrong. The surfaces of P are shiny, same deal. The surface of P have a smaller area than the surface of Q. This is not a reason for higher rate, this is a reason for a lower rate. So we are left with D, which says that the water in P is hotter than the water in Q. Higher temperature leads to higher rate of infrared emission. Question 20 says the diagram shows a wave. What are the amplitude and the wavelength of the wave? So this is not the amplitude, this is double the amplitude. The amplitude is 3 centimeters from the equilibrium position or the undisturbed position to a crest or to a trough. And the wavelength is between 2 corresponding points to identical points like a crest and a crest. So the wavelength is 8 centimeters. So we have amplitude 3 and wavelength 8. The answer is B. Question 21 says the frequency of the microwaves used in a microwave oven is 2400 megahertz. What is the wavelength of these microwaves? Microwaves are part of the electromagnetic spectrum, so the speed is 3.0 times 10 to the power of 8 meters per second, and we have the frequency equal to 2400 mega, that means 10 to the power of 6 hertz. So we can use the equation wavelength equals speed over frequency. So we divide 3 times 10 to the power of 8 by 2400 times 10 to the power of 6. That gives an answer of 0.125 meters, so the answer is A. Question 22 says an object O is placed in front of a plane mirror as shown. Which row is correct? The position of the image, it should be right in front of the object, so it should be 1. And mirrors always form virtual images if they are plane mirror, so these are the options, so the answer is B. Question 23 says which statement is correct? The speed of light in glass is equal to the speed of light in a vacuum. No, it's less. The incident angle of a light ray at an air glass surface is the angle between the ray and the glass surface. No, it's between the ray and the normal. The sine of the critical angle at an air glass surface is equal to 1 over the refractive index of glass. That is correct. The angle of refraction for light passing through an air glass surface is proportional to the angle of incidence at that surface. No, it is the sines of the angles that are proportional, not the angles themselves. So the sine of the angle in air is proportional to the sine of the angle in the medium, not the angles themselves. Question 24 says an intruder alarm sensor detects that a person is warmer than his surroundings. Which type of electromagnetic wave does the sensor detect? For heat, we have infrared radiation. Question 25 says a dolphin sends out a sound wave. An echo returns 0.010 seconds later from a fish, which is 7.5 meters from the dolphin. What is the speed of the sound wave in the water? So the sound travels 7.5 meters towards the fish and 7.5 meters back. So the total distance would be 2 times 7.5. So to calculate the speed, we use the equation twice the distance over time, since this is an echo. So 2 times 7.5 over 0.10. This gives an answer of 1,500 meters per second. So the answer is D. In question 26, it says 4 nails A, B, C, and D are tested to find which makes the strongest permanent magnet. One of these nails is placed against a bar magnet, and the number of paper clips which the nail can support is recorded. The bar magnet is then removed, and the number of paper clips remaining attached to the nail is recorded. Each nail is tested individually. Which nail becomes the strongest permanent magnet? So for strongest, we need the largest numbers. So A and B are omitted. Permanent magnet means after removing, you need a large number. So the answer is C. Question 27 says a student wants to demagnetize a steel bar. He uses the apparatus shown. He switches on the circuit for a few seconds and then switches off. He finds that the steel bar is still magnetized. What should he do to improve his method? Change the supply from an alternating voltage to a direct voltage? No, it should be AC. Use a lower alternating voltage? Has no effect. Remove the steel bar from the coil while the current is switched on? Yes. Use a coil that has a fewer turns on it? No. So the answer is C. Question 28 says a cloth is used to rub an uncharged plastic rod. Both rod and cloth become charged. Why does the plastic rod become negatively charged and the cloth become positively charged? Negative charges happen due to gain of electrons. Positive charges happen due to loss of electrons. So the rod gains electrons, that's correct. The rod gains electrons, that's correct. Loses, no. And the cloth gains positive charges. No, positive charges are not transferred. Only electrons are transferred. So the answer is B. Question 29 says a student uses a circuit shown to determine the resistance of two identical resistors. The voltmeter reading is 2.2 volts. That's the total voltage across the two resistors. And the meter reading measures the total current of 0.25 ampere. We are required to know each resistance of the two resistors. We can first calculate the total resistance using R equals V over I. So we divide 2.2 over 0.25. That gives a total resistance of 8.8 ohms. But that's for two identical resistors in series. So if we name them X and X, so X plus X or 2X is equal to 8.8. So X equals 8.8 over 2. which gives 4.4 ohms, making the answer C. Question 30 says a cell passes a current of 2 amperes in a circuit for 30 seconds. In this time, the cell transfers 120 joules of energy. What is the electromotive force of the cell? We can use the equation energy equals VIT, voltage times current times time. And we need to get the voltage, so V equals E over IT. So we divide 120 joules by 2 amperes multiplied by 30 seconds. This gives an answer of 2 volts, so the answer is C. Question 31 says the circuit shown contains 5 lamps J, K, L, M, and N. All the lamps are glowing. One lamp is removed and 2 other lamps go out. If you remove one component and other components fail to work also, this means that all these components are connected in series. So which lamp is removed? The lamp which is connected in series with 2 lamps. Lamp L is connected in series with all the rest of the lamps, so it cannot be L, since removing L would make the whole circuit stop working, not only 2 lamps stop working. Lamp J is in series with lamp K and N. So removing J switches off the current in K and N, and only lamp M and lamp L will be glowing. So the answer is A. Question 32 says, what is the effective resistance of the following combination of resistors? Here we have the 4 ohm resistor in series with the 2 resistors in parallel, 6 and 8. First, we calculate the total resistance of 6 and 8 by product over sum, 6 times 8 over 6 plus 8. This is the total resistance of the parallel connection. Then we add the 4 ohms as in series. This would give a total value of 7.42887 and so on, which we can approximate to 7.4, so the answer is B. Question 33 is about logic gates, which is not in the new syllabus, so you can skip it, but I will answer it. Which symbol represents a NAND gate? A NAND gate is similar to an AND with the circle up front. Question 34 says the diagram shows a circuit used to switch on a heater when the temperature drops below a certain value. Which row shows the components that should be connected at X and at Y? So we are depending on temperature, so no light dependent resistor, only thermistors. So it's either B or D. Then we decide which position is for the thermistor. Is it X or Y? So we need the circuit to work, which means we need the coil to be magnetized, which means we need high voltage at the coil and high voltage at Y. For a simple potential divider, by placing 2 objects in series, the higher voltages go to the higher resistance. So as temperature decreases, the resistance of a thermistor would increase, which causes the voltage across it to increase. So we must place the thermistor at Y, and since it is a set or certain value of temperature, X must be a fixed resistor. So Y would be a thermistor and X is the fixed resistor, so it's B. Question 35 says the diagram shows the magnetic field due to a current in a solenoid. Where is the magnetic field strongest? The strongest part of a magnetic field would show field lines very close to each other, so the part with the largest number of magnetic field lines is the strongest part, which is at the center of the solenoid, so it is C. Question 36 says a beam of electrons is passed through the magnetic field of a magnet. How must the magnet be positioned to deflect the beam in the direction shown, to the right? So first, electrons are neither attracted to south poles nor attracted to north poles, so A and C are omitted, and we use Fleming's left-hand rule to know the direction of deflection or the direction of the magnetic field or current. In choices B and D, electrons are moving out of the page, so the current is actually into the page, since current goes against negative charge. So pointing with the middle finger from the left-hand rule, the middle finger should be pointing towards the screen. Like this. The middle finger is into the page. Then we try to orient our index finger towards the south pole of each magnet in each diagram, and we see if the deflection is the same or not the same. So if we use the Fleming's left-hand rule as this, the middle finger into the page representing current into the page, and the index finger is pointing upwards from north to south, like the diagram. The thumb is actually moving to the right in the same direction of deflection of the beam. So the answer is B. Question 37 says uranium-235 can undergo nuclear fission in many ways. Which equation correctly shows a possible fission reaction for uranium-235? So we have one neutron and the uranium-235 nucleus in all of the choices are the same. And on the second side or the right side of the equation, we have some differences. So first we must balance the upper numbers. So 1 plus 235, that's 236. Adding 141 and 92 and 3 multiplied by 1, that actually gives us a total number of 236. Then we check the bottom numbers. So the total at the bottom is 92, the proton numbers is 92 in total. So adding 56 and 36 and 0, that actually gives a total of 92. So the answer is actually A, and we do not need to calculate the rest. They will be wrong. Question 38 says a radioactive material has a half-life of 20 days. A sample of the material contains 8 × 10⁻¹0 atoms. How many atomic nuclei have decayed, not remaining, after 60 days? Since you have the half-life and you have the total time, you can divide the total time by the half-life, 60 divided by 20, to know how many half-lives have passed. That's 3 half-lives. This means that the original number of atoms, you keep dividing it by 2, 3 times. You started from 8, divide by 2, you get 4, divide by 2 a second time, you get 2. The last time you get 1 times 10⁻10 atoms that remain. So the decayed would be 8 minus 1, which gives you 7 times 10⁻10 atoms that decayed, and the remaining were 1 times 10⁻10 atoms. Question 39 says a thin sheet of paper is placed between a radioactive source and a radiation detector. The count rate falls to a very low reading, which is background. From this result, which type of radiation is the source emitted? The only one that can be stopped by paper is the alpha particles. None of the others can be stopped by a piece of paper. So the answer is A. The last question says alpha particles, beta particles, and gamma rays are emitted by radioactive nuclei when they decay. Which emissions can be deflected by an electric field? They need to have a charge, so only alpha particles and beta particles, which are positively and negatively charged respectively, can be deflected in an electric field. Gamma rays cannot be deflected by electric fields. So this was the end of the exam. I hope you found this video useful, and I will see you in another video.